Look up. On a clear night, away from city lights, you see the band of the Milky Way. It looks like a river of milk. Peaceful. Silent. A static tapestry of ancient light. This is a lie. The tranquility of the night sky is a deception created by distance. We live in the quiet suburbs of the galaxy, 26,000 light-years from downtown. We are safe here. But if you could travel down that river of light, past the dust lanes and the star clouds, towards the constellation of Sagittarius, the silence would break. The peace would shatter. You would find yourself in a place where the laws of physics as we know them are tortured. A place of unimaginable violence, intense radiation, and gravitational forces so powerful they can rip a star apart faster than you can blink. At the exact center of our galaxy, driving the rotation of over 100 billion stars, is not a gentle heart. It is a monster. NASA has spent decades trying to see it. And when they finally did, the data revealed a reality more terrifying than any science fiction. Welcome to the dark. I am Stellar, and today we are traveling to the center of everything to meet the beast that holds our galaxy together, and ultimately will tear it apart. To understand the monster, you must first understand its lair. The journey from Earth to the galactic center is a descent into chaos. As you move inward, the stars do not just get brighter, they get exponentially denser. In our neighborhood, stars are light-years apart. In the central parsec of the galaxy, they are packed together like sardines in a tin. If you lived on a planet near the core, your night sky wouldn't be dark. It would be a blazing canopy of 1,000,000 stars, each brighter than Venus, casting shadows even at midnight. The radiation would be lethal. The stellar winds would strip an atmosphere in days. This is the central molecular zone, a region filled with dense clouds of gas and dust, the raw material for star formation. But here, birth is violent. The immense gravity from the center creates tidal forces that crush these clouds, triggering bursts of star formation on a scale we can barely comprehend. NASA's Chandra X-ray Observatory has imaged this region. It doesn't see visible light, it sees high-energy X-rays, the scream of matter being heated to millions of degrees. The images show thousands of point sources, neutron stars, white dwarfs, and smaller black holes, all orbiting the center in a frantic, relativistic dance. They are the courtiers of the king, and they are all terrified. Astronomers have tracked the orbits of individual stars in this region for over 20 years. One star, known as S2, orbits the center once every 16 years. At its closest approach, it is moving at nearly 3% of the speed of light. Think about that. A star, many times more massive than our sun, being whipped around like a toy on a string. What could possibly have the gravity to do that? What object is so massive, yet so small, that it remains invisible while swinging entire stars around it? For years, it was just a mathematical ghost. A point on a graph labeled Sagittarius A*. Then we built a telescope the size of the Earth to take its picture. But Sagittarius A* does not hunt alone. If you scan the darkness just 350 light-years away from the center, a mere stone's throw in galactic terms, you find something else. Astronomers call it 1E 1740.7 to 2942. But it has a much darker name. They call it the Great Annihilator. This is a stellar mass black hole, much smaller than the giant in the center, but far more aggressive. It is currently spewing out jets of high-energy particles that are slamming into the surrounding gas clouds. When these particles hit, they don't just heat the gas. They cause pair production. Matter and antimatter are being created out of thin air, only to instantly collide and annihilate each other in a flash of gamma rays. It is a pocket of pure destruction. A heavy metal machine gun firing into a crowded room. The existence of the Great Annihilator suggests that the galactic center is not just the home of one monster. It is a nest. How many other black holes are hiding in the dust, silent, waiting for a star to wander too close? We have found the loud ones. The quiet ones are the ones you should worry about. In 2022, the Event Horizon Telescope collaboration released the first image of Sagittarius A star. It wasn't a photograph in the traditional sense. It was a composite of radio waves collected by observatories all over the planet, stitched together by supercomputers. The image showed a fuzzy, glowing orange ring around a central patch of darkness. To the uninitiated, it looks like a blurry donut. To an astrophysicist, it is the face of terror. That dark center is the event horizon, the point of no return, the boundary where the escape velocity exceeds the speed of light. Nothing, not light, not information, not radio waves, can ever escape from inside that boundary. It is a one-way door out of our universe. The object inside that horizon is a supermassive black hole with the mass of 4 million suns, all crushed into a space smaller than the orbit of Mercury. The glowing ring is the accretion disk. This is matter, gas, dust, shredded asteroids, and obliterated planets that has been caught in the black hole's gravity but hasn't fallen in yet. It is orbiting at substantial fractions of the speed of light. The friction in this disk is unimaginable. The material is heated to billions of degrees, turning it into a plasma that glows brightly in radio and X-ray wavelengths. This is what NASA sees. Not the black hole itself, but its dinner plate. The image confirms Einstein's theory of general relativity in the most extreme environment in the galaxy. The gravity is so intense that it bends light itself. The back of the accretion disk is bent up and over the top of the black hole, so you are seeing the front and the back at the same time. Space is warped into a funhouse mirror of gravity. But A** is not a dormant beast. It is an active feeder. And when it eats, it is spectacular and horrifying. Our supermassive black hole is currently on a starvation diet compared to others in the universe. It's considered quiescent. But quiescent, for a black hole, is still cataclysmic by human standards. NASA's NuSTAR and Chandra telescopes regularly detect X-ray flares from our A star. These are cosmic burps, sudden releases of energy that occur when a clump of matter, perhaps an asteroid or a gas cloud, crosses the event horizon and is consumed. But sometimes the meal is much larger. Astronomers are currently tracking a mysterious object called G2. Originally thought to be a gas cloud, its encounter with the black hole suggested something denser at its core, perhaps a star. As G2 swung past a asterisk, the immense tidal forces stretched it out into a long, thin filament of gas. This is a process called spaghettification. Imagine you are falling feet first towards the black hole. The gravity at your feet is significantly stronger than the gravity at your head. You would be stretched vertically and compressed horizontally, pulled into a long, thin noodle of human matter before being ripped apart at the atomic level. This happens to stars. When a star gets too close, the black hole's gravity overwhelms the star's own self-gravity. The star is literally torn open. Half of its mass is flung out into the galaxy at high speed, and the other half is pulled into the accretion disk, causing it to flare violently. These are called tidal disruption events. We have seen them happen in other galaxies. It is only a matter of time before we witness one at the heart of our own. A star, a world that may have had planets, civilizations, history, gone in a flash of X-rays, converted into fuel for the monster. What happens past the event horizon? Science stops here. A mathematics breakdown. We are entering the realm of pure speculation and ultimate horror. According to general relativity, all the matter that falls in, the 4 million suns, the shredded stars, the gas, is crushed down into a single point of infinite density and zero volume at the center. The singularity, the point where space and time as we know them cease to exist. Some theories suggest that inside the horizon, time and space swap roles. You can no more stop moving toward the singularity than you can stop moving toward tomorrow. The future is not a time. It is a place, and that place is the center of the black hole. Others suggest it is a gateway, a wormhole to another region of space-time, or perhaps another universe entirely. A white hole spewing matter out somewhere else. Or perhaps it is just the end. A true, absolute oblivion where the information that makes up reality is deleted forever. We do not know. And we can never know. Any probe we send in can never send data back. The secrets of the singularity are locked away behind the ultimate firewall. We live our lives here on Earth, worrying about our small problems, protected by 26,000 light-years of vacuum. But everything we are, our sun, our planet, every atom in your body, is orbiting that monster. Sagittarius A* is the anchor of our galaxy. Without its immense gravity, the Milky Way would not exist in its current form. It is our creator. And one day, billions of years from now, when our sun is a dead white dwarf and the Andromeda galaxy has crashed into us, feeding the monster with fresh chaos, everything will eventually succumb to its pull. The center of everything is not a place of peace. It is a reminder that the universe is vast, violent, and profoundly indifferent to our existence. The monster is there. It is watching. And it is hungry. Pause. Let the silence hang. If this glimpse into the cosmic dark has awakened something in you, if you want to explore the terrifying reality of the universe based on hard science, then you are in the right place. Subscribe to Stellar's Dark. Activate the notification bell. Do not miss the next descent into the void. And tell me in the comments below, what do you think happens at the singularity? Is it a doorway or is it just the end? I'll see you in the next dark.